Welcome to Digital Earth Academy, a new program from the Denver Museum of Nature and Science designed to be a guide to our world as seen from above, high above, up in space. My name is Bob. I'm a geologist doing research for the Denver Museum of Nature and Science. And we're using a program called OpenSpace, funded by NASA. It's a lot like Google Earth, an app that you can use at home. Our first Digital Earth Academy is about ice and how it affects the Earth, our home planet. The Earth is a wet place, almost 3/4 covered in oceans. That's salty water. Most of the fresh water on our planet is frozen as ice. In this program, we're going to investigate how this ice affects Earth and its climate. This introductory video will feature some fun experiments to get the show going. The first experiment will demonstrate the importance of color on melting snow. Mitch, our museum educator, will lead the way.
Let's do an experiment. Now this is an experiment you can totally do at home. All you need is a black piece of paper, a white piece of paper, and 2 containers full of snow. Take the snow, put it on the pieces of paper, flatten it out a little bit, and then we wait.
Our next experiment will investigate what happens when water freezes. You may have heard that water expands when it turns into ice. This is a very powerful force that can break apart rocks and even mountains. Think about water trapped in small cracks in rocks. When it freezes in the wintertime, it can break the rocks apart. Ice can also flow as glaciers, moving rivers of ice that can carve valleys. Our next experiment shows the effect of water expanding when it is frozen. Here comes Mitch to show us how.
Let's do an experiment. This experiment will help us look at how much water expands as it changes state into ice. And this is an experiment you can totally do at home. You may actually have done this experiment at home by accident before. All you need are 3 identical bottles of water. Now this first bottle of water, we're just gonna put in the freezer as is and see what happens. This second bottle of water, I'm gonna dump out about half the water and then put a piece of tape around the water line, which I actually did before. Here it is. And so then maybe we can see exactly how much the water expands above that line. And this third bottle of water, I'm not gonna do anything to. This is our control bottle of water that we'll leave out here unfrozen and we'll be able to compare exactly how much it changes. So we'll put these 2 in the freezer and then we wait. All right, it's been about 24 hours. It's time to check on the results of our experiment. Now this is our control water bottle. It looks the same. Good, that's what we thought. This is the water bottle we put in the freezer without doing anything to. Now at first glance, they might not look that much different, except that one's full of ice, that one's full of water. But look at them right next to each other. The frozen water bottle is significantly taller. As the water froze and the ice expanded, it pushed out these little wrinkles in the bottle, and that bottle actually grew taller. And you can see kind of a bulging shape down here at the bottom. And at the very bottom, this water bottle has a nice indentation, which allows it to stand really easily. This one, it's pushed out and it's kind of rounded, which means that this water bottle is much more difficult to get to stand up straight. Oh, there it goes. Okay, whoop. Now let's look at our bottle with the tape on it. Here we go. And as you can see, the ice has frozen a little bit above the tape line, but we also have kind of a bulge out at the bottom and a sort of rounded end, not as much as our full water bottle, but still, we've got some expansion. This was maybe, I sort of assumed the water would mostly freeze up, and it didn't. It expanded in every direction at the same time. So if you do this experiment at home, which I hope you will, it's super fun, maybe you can figure out other ways to examine just how much the ice freezes and in what direction. But if you do it at home, please do not use a glass bottle. If you use a glass bottle, it will shatter and you'll get ice shards in your ice cream. But you should definitely do the experiment, because experiments are super fun.
Did you know that ice can also be sticky? You might have tried to pick up an ice cube when your fingers were wet, and you might have noticed the ice cube sticks to your fingers. Our museum educator, Asa, is going to demonstrate another way that very cold things can be sticky.
We know that ice can do amazing things. Glacial ice can carve through mountains, icebergs can sink Titanic boats, and if you're not careful, it could freeze your tongue off. Maybe you've seen a movie where some kid sticks their tongue to a really cold pole. Well, I've got a tongue and I've got a pole, so let's see if that's really what happens. But first, some safety equipment. Coat, goggles, gloves, and for our experiment, liquid nitrogen. Now this liquid nitrogen is negative 320 degrees, so it is incredibly cold. As you see, as I pour this liquid nitrogen, there is a mist forming around it. It is taking the water vapor around and condensing it into a fine mist. Now we're ready to chill this pipe. Now, what you're about to hear is some sizzle and some fizzle, and you can see the water vapor coming out of the pipe, because this liquid nitrogen is negative 320 degrees. That means that this pipe is relatively boiling at room temperature. You can even see the liquid nitrogen popping out of our container right here as I submerge it further and further as the pipe gets colder and colder. And that way we know that this pipe is at negative 320 degrees Fahrenheit. Here we go. I'm gonna do it. I'm gonna do it. Don't do this at home. All right, so I didn't actually stick my tongue to the pole. That'd be yonkers and bonkers. Look at that thing, it's stuck to the pole. That'd be bad news for a real tongue. As you can see, my tongue got really hurt. Okay, not my tongue, thankfully, because we were being safe about it. But if you actually stick your tongue to a really cold pole, you can see what the results are. That's just one example of the amazingness of ice.
Thank you for joining us on this introductory video. We hope you now will be able to join us for the whole program, our first Digital Earth Academy.